survived the journey are called meteorites. Travelers through space and time, meteorites are tiny fragments of their original bodies. Asteroids, comets, moons, and planets. Crashing into the atmosphere at speeds of 32,000 to 150,000 miles per hour, many land in our oceans, never to be recovered. Those retrieved from icy landscapes, deserts, and sometimes highly populated areas reveal the mysteries of our solar system's formation and the history of the planets. More than 4.6 billion years ago, the solar system began to evolve out of a gigantic cloud of dust and gas. Within this huge cloud existed many smaller, dust-rich regions. One such region collapsed and spiraled inward. Most of the material accumulated in its center, while some particles dispersed, forming a rotating disk called the solar nebula. The dense core of the solar nebula heated to extreme temperatures and ultimately became the sun. The remaining gas and dust particles collided, gradually forming larger objects. Some became planets, others became comets, or the most common source of meteorites, asteroids. All of these bodies share a common ancestry, those first dust particles billions of years ago. The study of meteorites allows us to trace this ancestry. The chemical evolution of the entire Milky Way galaxy may be stored in a piece of meteorite small enough to fit on your fingertip. Before the sun and solar system even existed, an earlier generation of stars exploded. They released tiny grains, including diamonds and graphite, that spread across the galaxy. By isolating and studying pre-solar grains buried within meteorites, scientists are able to chart the evolution of ancient stars from the confines of their laboratories. New developments in nanotechnology allow cosmochemists and astrophysicists to reach new microscopic depths, discovering pre-solar dust particles that can be smaller than 100 nanometers or 1/10,000,000th of an inch. Recognized as the smallest and oldest relics of the galaxy here on Earth, pre-solar grains record billions of years of cosmic history. Despite their tiny size, they provide unique information about the evolution of stars outside our solar system. If you could actually cool a piece of the sun enough to hold it in your hand, it would have the same composition as many primitive meteorites. When clumps of dust grains in the solar nebula melted billions of years ago, they cooled quickly and formed glassy beads called chondrules. In the early solar system, chondrules combined with mineral grains and other objects to produce larger bodies. Today, these bodies exist as asteroids, the source of most meteorites. Despite their long and fiery journey to Earth, meteorites from these asteroids have remained intact and unchanged since their creation. Using computed X-ray tomography, similar to medical CAT scan technology, scientists can see and analyze the dust and chondrules within a small portion of a meteorite.